A team building a retrieval augmented generation application on a budget needs to solve several problems at once. They need a free LLM API that provides access to capable language models without a per-token billing account, a knowledge base that stores and retrieves documents for the RAG pipeline, a charting layer for visualizing retrieval quality and query performance over time, access to Google APIs for connecting the application to existing organizational data in Sheets, Drive, and Calendar, and a containerized runtime that keeps the application portable across developer machines and deployment targets. Without these layers working together, the team either pays for LM usage before validating the product or spends weeks integrating a local inference setup that is slower than necessary for interactive use. With a RAG workspace built from these 5 repositories, the team can query organizational data, retrieve relevant documents, generate grounded responses, visualize retrieval quality, and deploy consistently, all without an LLM billing account. Freellmapi provides the language model access layer. It is a community-maintained proxy and aggregator that provides free access to several capable language model APIs through a unified, OpenAI-compatible endpoint. The RAG application sends completion requests to Freellmapi using the standard OpenAI client library, which means the application code does not need to change if the team later switches to a paid provider. Only the base URL and key configuration change. Onyx provides the knowledge base layer. It is a markdown-based note-taking and document management system with a REST API, tag-based organization, and backlink graph for navigating related entries. The RAG pipeline indexes team documents, meeting notes, project specifications, and reference materials as Onyx entries. When a query arrives, the pipeline searches Onyx for relevant entries and passes the retrieved text as context to the Freellmapi completion call. Recharts provides the analytics visualization layer. Retrieval precision over time, query response latency distributions, document hit rates by topic, and Freellmapi response quality scores are rendered as Recharts charts in the team's internal dashboard. These charts let the team identify when retrieval quality is degrading or when certain document categories are consistently missed by the search layer. The Googleapis package provides organizational data access. The RAG pipeline connects to Google Sheets for structured reference data, Google Drive for document discovery and ingestion, and Google Calendar for time-sensitive context like meeting summaries and scheduled deadlines. These connections feed fresh organizational data into the Onyx knowledge base automatically. Container provides the deployment layer. The Freellmapi client configuration, the Onyx connection settings, and the Python dependencies are packaged into a version Docker image that every team member and CI environment runs identically. Following a single query from submission to grounded response shows the data flow through all 5 repositories and explains why each layer handles its responsibility exclusively. The query starts when a team member types a question into the workspace interface and submits it. The backend receives the query string and passes it to the Onyx search layer. Onyx searches its indexed documents using tag matching and full text search, returning the top matching entries ranked by relevance. The interfaces between Onyx and the retrieval layer are the search query string and the response array of matching entries with their content and metadata. The retrieval layer selects the top 3 to 5 entries based on relevance score and character budget, then assembles them into the context block for the language model call. The Freellmapi client sends a completion request with the retrieved context and the original query formatted as a system user message pair. Freellmapi routes the request to an available free model endpoint and streams the response back to the application. The application displays the streamed response in the workspace UI alongside the source citations, the Onyx entry titles and tags that contributed to the context block. The query event is logged with its metadata. The query text hash, the number of retrieved documents, the Freellmapi response latency, and a simple length ratio used as a response quality proxy. These metrics are written to the application's metrics store and visualized in Recharts on the analytics dashboard. The retrieval precision chart updates with the new data point, showing which document categories contributed to this query and whether the response met the expected length threshold. The Googleapis layer runs on a separate schedule. A daily ingestion job reads new documents from the configured Google Drive folder, extracts their text content, and creates or updates the corresponding Onyx entries through the REST API. A Sheets ingestion job reads the team's reference data tables and updates Onyx entries tagged with the sheet identifier. This keeps the Onyx knowledge base synchronized with organizational data without manual copy-paste. The container image ensures the Freellmapi client configuration, the Googleapis credentials path, and the Python dependencies are identical across all environments. Running the workspace in a new environment requires only pulling the container image and injecting the environment variables. The build order starts with Onyx, since the knowledge base must contain documents before the retrieval layer can be tested. Deploy Onyx in server mode and create the initial folder structure, one folder per project the RAG workspace will cover. Import 20 representative documents, meeting notes, project specs, and reference materials through the REST API. Test the search endpoint with 10 queries that have known correct answers in the imported documents and measure the retrieval precision for this baseline set. Record the precision scores before connecting Freellmapi, since they represent the retrieval layer's performance independent of the language model. Set up the Googleapis ingestion layer next. Configure OAuth2 credentials for the Google Drive and Sheets APIs. Load them from environment variables in the ingestion script, and run the drive ingestion against a folder containing 10 test documents. Verify that each document appears as a correctly tagged Onyx entry with the expected content. Test the Sheets ingestion against a reference table, and confirm that the resulting Onyx entries contain the structured data, in a format the retrieval layer can match against user queries. Configure the Freellmapi client. The interfaces between Freellmapi and the RAG pipeline are the OpenAI-compatible chat completion endpoint and the streaming response format. Test the client with a prompt that does not require retrieval context, a simple factual question, and confirm that the response streams correctly and that the latency falls within the team's acceptable range for interactive use. Then run a full RAG pipeline test. Retrieve context from Onyx for 3 queries in the baseline set and confirm the responses are grounded in the retrieved documents. Security in this stack requires that the Google OAuth2 token and the Freellmapi API key be loaded exclusively from environment variables. The Freellmapi key must not appear in container image layers or application logs. The Googleapis scopes must be restricted to the minimum required. Read-only access to the specific drive folder and Sheets document identifiers configured for ingestion. Failure handling in the Freellmapi call applies a retry when the endpoint returns a rate limit or gateway error. After 2 retries, the workspace returns a fallback response indicating the language model is temporarily unavailable and displays the retrieved Onyx entries directly, so the team member can read the source documents without waiting. Deploy Recharts as part of the Analytics dashboard build. The container image is built and tested last. The production deployment is complete when the daily ingestion job, the query pipeline, and the Recharts dashboard all operate without manual intervention. The documented configuration of each repository defines the workspace's coverage and cost constraints. Freellmapi is MIT licensed. Its documentation covers the base URL configuration for the OpenAI-compatible endpoint, the available model identifiers and their context length limits, the API key format, the rate limit policy for free tier usage, and the streaming response format. The project notes that available models and rate limits change based on provider contributions to the aggregator, and that the endpoint should be treated as best effort for production use. Onyx is MIT licensed. Its documentation covers the REST API for creating, searching, and updating notes, the tag and backlink configuration, the folder hierarchy for organizing documents by project or source, the webhook format for receiving entries from external ingestion pipelines, and the full-text search query syntax. The project runs as a local desktop application or a self-hosted server with no external database requirement for single-team deployments. Recharts is MIT licensed. Its documentation covers the chart component types, including line chart, bar chart, area chart, and scatter chart, the data binding format with named data keys, the responsive container wrapper for fluid layouts, the tooltip and legend configuration, and the axis scale options for linear and logarithmic displays. The Googleapis package is Apache 2.0 licensed. Its documentation covers the OAuth2 credential configuration, the drive file list and export API for discovering and downloading documents, the Sheets Values Read API for retrieving structured table data, the Calendar Event List API for ingesting meeting summaries, and the scope definitions for restricting access to specific APIs. Container refers to Docker, which is Apache 2.0 licensed. Its documentation covers the Dockerfile format for defining the application environment, the environment variable injection at runtime, the volume mount configuration for persistent Onyx data, and the multi-stage build pattern for minimizing final image size. The fastest path to a working RAG workspace is deploying Onyx, importing 10 documents, and running one query through the Freellmapi client with retrieved context. With a grounded response confirmed, the Googleapis ingestion and Recharts analytics can be added incrementally. Which organizational data source would make your team's RAG responses most useful immediately?